I warmly welcome you, Professor Nelles from our University in Rostock. You will give us important insights in the fields of waste management and smart bioenergy. And as one of our most important tasks for the future is to supply national economies with raw materials and energy in an economically, environmentally, and socially sustainable way. So also when it comes to bioenergy, Germany has to change its energy supply to renewable energies. And the supply of organic raw materials must shift to bio-based materials in order to achieve climate neutrality. You are an environmental engineer, and since 2006, you're a full professor of waste and resource management at the Faculty of Agriculture and Environmental Sciences at the University of Rostock. Since 2012, you are also the scientific director of the German Biomass Research Center in Leipzig. Thank you very much for being here, and we can start now.
Yeah, thank you very much for inviting me, and thank you very much for the introduction. I will go to the slides. I prepared a mixture of this, what Elisabeth Reich mentioned in some sentence before, and I focus on the recovery of organic waste and residues in Germany. And there we have the link to bioenergy on one hand and on waste management on the other side. So I think I need 45, maximum 50 minutes for the presentation. And then we have the possibility to discuss some points if you are interested in. So you see some other names here in the first slide. Gerd Norschek is working here in the group of waste and resource management at the University of Rostock. The same as Abdallah Nassour. Both are very experienced experts in waste management. They are working for more than 30 years in this field. And Satya Nara is also one of the assistant professors in Rostock at our department, and he's also involved in different projects at the DBFZ, where I'm working too. So this is the group, and we prepared a mixture to all the topics, the role in waste management, the energy system, the link to bioeconomy, and the relationship to the climate protection. I think you heard some presentations, so you also get some insights about the University of Rostock. So I will skip this and go only in the part on the left side. We are working here at the Faculty of Agricultural and Environmental Science, and my department for waste and resource management. We have three topics, main topics. The first one is waste management, and we are engineers, so we are focused on the waste technologies. Then we have big activities in the international environmental protection field. 2/3 of our projects are in the international fields. We are focusing on the Asian region. China and India are the main countries where we are working. We are focusing on the Arabian countries, because Abdallah Nassour is one of the leading experts in this region, especially for waste management. And we have the link to bioenergy. This is also internally important, because we are the Faculty of Agricultural and Environmental Science. So 2/3 of our faculty are experts in the agricultural field. So they are all handling with biomass in the internet in different ways. And it's also the external link to the DBFZ, where I'm working too. Some information about the DBFZ you can see here. It's the central Center for Biomass Research in Germany. It's a part of the German government, founded in 2008, and we have a good development. Now we are more than 200 experts in this institute, and we had good scientific results. So the government will invest more than 60 million euro in different buildings and also in new stuff and so on. You can see here that we have 4 departments, and 3 of them are focusing on technical development, and the bioenergy systems department is more handling the paperwork to develop these things. I will focus a little bit later on these issues. So I will go through 5 topics in general. The first part, some general information about waste management in Germany and the development in the last 40 years. Then the biomass in the German energy system, what's the status over there, and then different examples of energy and resources from organic waste and residues, what we are working, and then a short outlook in the future. We create, as the DBF says, a smart bioenergy concept, and we try to implement this in the next 10 to 20 years. And this is the content of the next around 40 minutes. Some information about the waste management in Germany in the 1950s of the last century. We have no waste management. We have only a lot of dump sites, more than 50,000 in Germany, and this was a very strong environmental problem. So we produce a lot of waste and put it everywhere in the environment. So in 1972, it was the first Waste Management Act. And there we start with the modern waste management in Germany. This was also in the 1970s in the western part of Germany, where we had the first full study program of technical environmental protection at the Technical University of Berlin. And I was one of the students some years later, so I started in 1986 with this study program and focus in the master part of the study program to waste management. Then we have strong development in Germany of waste management. We have the separate collection. This is the main and very important step to get good secondary products out of the waste. This was one point. We had the first steps of extended producer responsibility. We developed a lot of recycling technologies, and a very important step was 2005. There we have the decision that it's not possible in Germany anymore to landfill untreated organic material, because if you put it on a landfill site, you have a lot of methane emissions because you have anaerobic situation in the landfill sites, and this was one very important issue that we do this. We know this 20 years before, but we needed a lot of time in Germany to implement it in law. So this was 2005. Then we had the first steps in a circular economy. I will show you a little bit later. Germany is one of the leading countries in the issues of waste management, and here you can see what we all need if we want to implement a good working waste management system. We need the law and ordinances. In Germany, we have a lot of law and ordinances based on the European level. Then we have the Federal Ministry of Environment in Germany and the environment ministries in the federal states we have in Germany. The municipalities are very important because they have the administration and the management of the waste management as one important target. And here you see more the technical and logistic part. In Germany, we are very good to develop the recycling technologies, and this was also an important issue. One reason why we are very successful comparing with other countries is that we have private and also municipal companies for the waste management in general. And we have the universities, they are working closely with the practical companies and also with the municipalities and develop the waste management system in the last 40 years. So this was an important issue. Here on the left side, this is also very important. We have a lot of countries all over the world. They have the main goals, like in Germany, what they have to do with the waste. But if there's no control, no strong control from the environmental agency, then nothing happened in practice. And in Germany, this is working very good. So what we have in the global scale is more the linear economy, and in Germany we are in the middle part, that we have a good waste management with some internal recycling and so on, but we have also a lot of non-recyclable waste, and so we have to develop it further that we can go to a circular economy, that we have the production, use and recycling more in a circle. If not, we use too much of raw material, and so this is the target for the next 20 years. We have in Germany an advisory council for environment, and the main points we have to do towards a circular economy. You can see in this chart, we have to reduce the material flows, and very important is the designing of products that it fits in a circular economy, that it's possible to circulate more than one time, and then we have the possibility to create a real circular economy. The other points are the waste management issues in a way that we have the avoidance of waste. This is the main point, but there we in Germany are not very good. As I mentioned before, in the recycling, we are in good shape. We have a lot of technologies, and also for the further utilization in incineration and landfilling, we are on a good technical level. As I mentioned in the beginning, it's very important that we have a separate collection of the waste we want to recycle. If we have a good separate collection of paper and cardboard, it's possible to produce new paper and cardboard from this source. We have the lightweight packaging from waste, where we can separate afterwards plastic, aluminum, and other materials. And I will focus today more on the organic waste. There we have the first steps 30 years ago to the separate collection of organic waste. And this is also a very important issue to create fertilizer out of the organic waste. We have a problem in Germany too. We have too much of residual waste, so 25% around. We have in the residual bin, and I will show you later a little bit that there is a lot of recyclables in, and we have to increase our separate collection in the future. Here you can see how it's organized in the city of Rostock. It's a separate collection of paper, the yellow bin, then we have glass in a separate collection, and I will focus more on the organic waste and give you some insights of this. In Germany, we have roughly 16,000 of waste treatment plants, and here you can see how it's shared. We have sorting and processing plants. These are nearly half of it. Then we have biological treatment, composting, and also anaerobic digestion, so-called biogas plants. We have the thermal treatment plants, for example, for waste incineration. We have also one here in Rostock. We have also the possibility to use special waste streams in the cement industry, also in coal-fired power plants, and so on. So we have roughly 800 thermal waste treatment plants. We also need landfilling of the inorganic material. There we have a lot of plants, and the 500 plants for chemical physical treatment. This is for wet waste streams of the hazardous waste. So in general, we have a good waste treatment plants viable in Germany, so that we have a good working waste management system. The new state of the board is focused on the year 2020, and there you can see the main data. We have 10,000 municipal and private companies in this area. We have roughly 270,000 employees are working there, and the turnover is more than 70 billion euros. So it's also an economical player in Germany. Here you can see the waste streams we have in Germany, only that you get a better feeling of the numbers. We have more than 400 million tons in general every year. More than half, you can see here on the right side, it's construction and demolition waste with 220 million tons. Then we have the commercial and industrial waste, the residues from the waste industry, mining, and I will focus on the municipal solid waste more from the households, and focus in more on the bio waste that we have 10 to 12 million tons every year. You can see here what I mentioned before, the different treatment facilities we have in the next chart. You see the same numbers from the last, and we have an output, and here you can see the problem in below. We have only a small share that we can use as a secondary raw material and energy, and this we have to optimize in the future, that we have a real circular economy. That we are on a good way, you can see also in this chart. Here you can see the greenhouse gas emission of the waste sector in Germany, the development from 1990 to 2020. And in 1990, we had a real big problem with the landfill side, as I mentioned before. We have a lot of methane emission, and this is for the climate a real problem. In 2005, we prohibited the direct landfilling of organic waste, and we also have the recycling of metals, glass, and so on. So now we have a mitigation effect, a positive one. So the waste sector is the most successful sector of all in Germany, focusing on the climate protection in the end of 2020. So I think this is enough for the introduction of the waste management in Germany. Now I will come more to biomass in Germany in the energy system. and give you some short insights. We have different sources of biomass reuse. We have energy crops, what we have in the landfill, in the agricultural area. We have the byproducts and residues, also from forestry, from the agricultural field. And we have the organic waste streams I mentioned before. We have the food waste, the garden waste, also the waste wood, and so on. It's a complicated field. You can see here we have a lot of sources of biomass. You can see in the first lane from agriculture, from forestry, from the waste part, and also aquatic biomass we can use. Then we have the biomass supply, inclusive the logistic area, and we have different technical possibilities for biomass conversion. We can produce everything, but not everything is sustainable. And afterwards, we can create a motor fuel for the mobility, electric power, heat and cooling. And because it is a very complex field, this was one reason to founding the DBFZ in 2008. If you see the development in the energy system, there you can see we are in the beginning of changing our energy system. We need 100% renewable energy system. And here are the data from 2017. Now we are a little bit further. Now we have 15% renewables, but also 15% it's not a good result because 85% are based on fossil fuels. You can see here that biomass is right now the most important renewable energy source. The reason is that we can produce everything, not only electricity, also the fuel sector and so on. And here you have to add also the biogenic waste as another percent. So in general, 8% of this 13% are based on biomass. The renewables have a very positive effect on the greenhouse gas savings by the renewables in Germany. And here you can see that we have savings of roughly 180 million tons per year. This is a big share. And also here you can see the green bars. This is based on biomass. In the electricity, it's only a small part, roughly 20%. But in the heat and the fuel, it's more than 90% comparing with the other renewables. So this is the main reason why we have a lot of biomass in the energy system. Now I will come to the main part of the presentation, the energy from biogenic waste and residues in Germany. I will give you some examples. First, here's an overview about the biogenic residues and waste streams. It's a big amount. You can see here we have a theoretical potential of roughly 240 million tons. And this tons is dry matter. So the water is out or not counted. So if you have the original matter, you have more than 600 million tons. You can see here a lot of organic residues we need at the field and have to leave it in the forest for the ecological aspects. But we have also 112 million tons of dry matter, what we can use for material and energetic use. And this is the basic where we are working with, and therefore we have a big amount. If you have a truck chain with this 112 million tons of dry matter every year, you have a loop more than 3 times around the globe only from the residues we produce here in Germany. So this is the fact where we are working, and I will give you some examples. The animal farming, we have a lot of pigs and cows, and they produce a lot of cattle slurry, pig slurry, cattle manure, pig manure, and chicken manure. And we have investigated that we have a theoretical potential of roughly 19 million tons of dry matter. It's possible to use in a technical way roughly 14. And if you take this, you can see we have now only 1/3 in a sustainable way of treatment, and 2/3 we are going directly to the agricultural field with a lot of problems for the water balance and also other points. So this is one point where we have to work in Germany. A good way to handle these things and have a better ecological result is that you put the residues in a biogas plant. There we built a lot in the last 20 years. Now we have roughly 10,000 biogas plants, and you can see they are spread all over Germany, and we have installed electricity capacity of 6 gigawatt and also can use the heat of the biogas plants afterwards, and this is one possibility to handle these residues. For us, it's very important to see Germany is a small country with 80 million people, so it's 1% of the global inhabitants we have. So we have to work, especially with the big countries like China, to find sustainable solutions. There you have 1.4 billion people, so it's nearly 20 times more than in Germany, and there we are working closely together with the partners to find solutions in, for example, this way of residues from the agricultural field. This was very successful, and we hope we can do other projects in the future. Some words about biowaste worldwide in Europe and Germany. You can see here the main problem we have with food loss and food waste. If we put it together, all the emissions we produce from food loss and the biogenic waste worldwide, and compare it with countries, then food loss and waste is the third largest greenhouse gas emitter, comparing after the United States and China. If you compare it with the transport sector, it's also on second place after the road transportation. So this is a real global problem we have to focus on if we will create a climate neutral society in a global scale. Now we come to Europe. You can see here we have also in Europe a lot of problems. If you only take a look to the household waste, 40% is biogenic waste, what we have in a separate collection. We have a lot of European countries, they don't have the separate collection, and so a lot of this amount are going directly to the landfill sites, as I mentioned before, with a lot of methane emission. Only 1/3 is in a separate collection going to composting and biogas plants. here you can see the framework in Germany, what we can do also with the organic waste. We have the possibility to go in composting facilities and also anaerobic digestion. And the best way is a combination of both. As I mentioned before, it's very important that we have a separate collection of the bio-waste to reduce the waste amount in general and to don't have the problem with methane emissions on the landfill side. We have the reduction of the biological fraction in waste. Also, we have less water, and then it's it's a better way to go to recycling. And there's a lot of detailed arguments to have a separate collection, and this is a very important issue. You can see the amount we have in Germany. We have roughly 14.2 million tons of biodegradable waste collected, and nearly half of them are going to composting plants, and the other one are going to the anaerobic digestion. This is optimal way we implement in Germany often, that we have organic waste more from kitchen waste. This is very useful for the fermentation in biogas plants, and the residues afterwards are going to composting with gardening and park waste. They have also a lot of woody biomass in, and this is possible to use also in a biomass power plant, so we can produce biogas, fertilizer from compost, and also electricity and heat. And this we implement in Germany, and you can see here the development up to the year 2070. This is a basic layout of a composting plant. You can see here the delivery of the waste, and we have a simple pre-treatment, a mixing, and then the rotting with air, and post-treatment afterwards. And after 10 to 12 weeks, we have a high-level compost with high quality we can use as a fertilizer on the agricultural field. This is working very well. We have the so-called Bundesgütegemeinschaft compost. They are for the quality check responsible, and you can see most of the compost is going to the agricultural field. On the other side, we have different technologies. Due to the limited time, I can't go more in detail to the biogas area. There we have different possibilities we can use and produce methane on the other hand for the energetic use. And we have a digestate, and this we can also use in a high quality in the agricultural field. You can see here more than 97% are going in this direction. We have also good quality if we focus on heavy metal content, so this is not a real problem. Also the organic pollutants on a very low level, so this is not a problem. But we have currently one main problem in the quality check there. We find too much plastics, and this is one main goal we have to create in the future, that we find a good way to produce compost with a very low content of plastics. This is one important issue to have this way also in the future. As I mentioned before, we have the separate collection of bio-waste, but we have also the residual bin, and on the left side here you see the situation in Germany. Roughly 40% of the residual waste is native organic waste. This is kitchen waste or garden waste, and this is a problem because we don't have optimized the system of separate collections. There we have to go further because This is a source for secondary fertilizer, and if we want to create a circular economy, we have to find a good solution. In Germany, the residual waste are going to 80% in waste incineration plants. You can see here we produce energy and also slag and other recycling material we can use afterwards. We have also the possibility to combine waste incineration with mechanical biological treatment. You can see in the middle part, and as I mentioned before, since 2005 it's prohibited to go directly to the landfill sites. This is a different possibility for mechanical biological treatment facilities. They are also working very well, and they have an input in Germany of roughly 5 million tons a year. Some words to sewage sludge is also a hot topic right now, also a discussion here in Rostock, if we should create a sewage sludge thermal treatment facility. Today, the court of the city is also discussing what's the best way. And here you can see the development or the status right now. There are data from 2016, but there was no change, much change afterwards. So it's also right now we have roughly 1.8 million tons of dry matter every year from the wastewater treatment facilities. And you can see 2/3 are going to thermal treatment facilities, and 1/4 is going to agricultural field. But there we have also the problems with pollutants, and so we decide in the long term we all will go to incineration facilities, and then we have to find a way to get out the phosphorus of the slag to give it back to the agriculture. This is one of our main working areas in this field. You can see here the development, and in 10-15 years we will have all this sewage sludge in a thermal treatment with the recovery of phosphorus, because this is also very important goal. Right now we have different combustion plants we use. We have a specialized monocombustion plants for the sewage sludge. This is nearly half, nearly 50%. We have also the possibility to use it in cement works, in normal waste incineration plants. We also have the possibility, and then we have the coal-fired power plant for the next 10 years we can use, and after that we will have roughly 80-90% monocombustion plants for this waste stream. Some information about the utilization of organic waste, but also other waste in the cement industry. I put some slides together. In Germany, we have roughly 50 cement plants all over Germany, you can see in the map. And they use right now 2/3 of waste fuels. So 2/3 of the energy the cement plants they use are coming from waste streams, and this is also a sustainable way. You can see the cement process in general. I don't want to go in detail. Here you see the central cyclone pro heater here on this area, and the rotary kiln is a very big unit with high temperatures over 2000 degrees Celsius, and there you can use also different waste streams. You can see the development of using waste streams in the cement industry, and the share of alternative fuels was increasing over the last 20 years, and now we are in the area of 2/3. And we have also we did some research projects in the past, also some PhD projects, and there we showed that it's possible to have cement kiln are working with 100% of waste streams, and also in touristic areas this is possible with a very high level on technical environmental protection, and this we showed in different projects. You can see some examples what's going in these cement kilns, and some of the waste streams are bio-based. The wood chips you can see here. The municipal waste, there's also partly I showed you of organic waste. We have rice husk we can use. Sludge is also more than 60% bio-based, and the rest is sand and so on. We have also meat and bone meal we use, so different waste streams are going to the cement industry. You see some numbers. This you can look afterwards. I will send also the presentation. If you are interested, you can take a deeper look about the mass balance in this area. The last chapter of the presentation, I will look a little bit in the future and give you some insights about the so-called small bioenergy concept we developed at the university and also in combination with the DBFZ. First of all, we have to state that biomass is a very limited resource. We have a big amount, but we have also different use that we need for in the global scale. So the first step is that we use biomass as food. The secondary step is the material use. And afterwards, if we have all these possibilities are in a good shape, then we can use the residues to produce energy. This is our sustainable work for the future, and we put it in one picture to have a simple idea of the smart bioenergy concept combined with the circular economy. We are started with bioenergy some thousand years ago. Today we have a good development of the different technologies for wind, for solar, and for bioenergy, and now we combine these to have 100% renewable energy system, and this is the energy for the circular economy. And we have to find a way to have a bio-based economy in the future. We are coming from the fossil economy, and now we have to develop in the next 30 years a bio-based economy, also in a circular way. So this together, energy and material in a circular way, bio-based, this is the main part we have to do. Here you can see that it's a complex field. We have a lot of sectors: agriculture, forestry, processing industry, engineering, the chemistry and pharma industry, the sector of energy, and also waste management. And we have a lot of targets we have to fulfill, and this is not so easy to do everything in the right way, but this is our goal. Here you can see some example of a bigger so-called bioeconomy cluster we create in the northeastern, in the eastern part of Germany, with the focus Leipzig, Leuna, in the southeastern part, and we had a funding of the BMBF with 40 million euro, and also as the industry invest more than 40 million euro, and we have to create a wood-based bioeconomy hub in this area. We had companies and institutes are working in the chemical area, material, and the DBFZ was more involved in the bioenergy field. You can see here some products we developed. We have bio-based chemicals. We have also for the construction material, then we have bioforms. We have bio-based plastics, construction material, and so on. And the DBFZ was involved more in the bioenergy field. So you can see what we did in the last 10 years. We are starting in the lab scale, and now we are building up bigger companies here in the industrial production. So this is working very well, and the DBFZ was involved to produce in a sustainable way the bioenergy for this field. Here you can see another example. This is a typical biogas concept we have right now. We use biomass in the best way. We have a lot of waste and residues we use. Then we have the digester. We produce methane. This is going to a combined heat and power unit. We produce electricity and heat, and the electricity is going to the grid. We have the digestate, there we can produce the fertilizer. So today we produce energy, electricity, heat, and we can also use the methane as fuel, and the material utilization is fertilizer. Now we are working on a flexibilization of the biogas production. There we have also different possibilities. This is one main area where we are working with the DBFZ with more than 40 experts to find solutions for the 9,000 to 10,000 biogas plants we have in Germany. And here's another example. You can see that we add some points to produce not only biogas and fertilizer, that we increase the development, that we have not a simple biogas plant, that we have more a biorefinery and produce chemicals also for the chemical industry. There we have also a lot of projects at the DBFZ and in cooperation with the department here in Rostock. This is the last slide. I hope I could give you an insight on what waste management is in Germany, what was the development in the last 30 years, and especially focus a little bit on the organic waste streams. I would also gave you an introduction of bioenergy in general, what's going on there and what we have to do also in the future. And here are only some conclusion and outlook points. In 2050, we need a global energy system based on 100% renewable energy. This is a very important goal, but it's a very strong goal to reach in a global scale. I think we in Germany have a chance to realize it 2040, 2045, but there's a hard way to go also for Germany. Then we need a bio-based economy, and then we have the possibility to get a climate neutral society worldwide. The utilization of biomass and particularly organic waste and residues is a key element of this point, and we have to use it in the energy system on one hand and in the bio-based economy on the other side. And as I mentioned sometimes in my presentation, we have the waste segregation at the source. It's very important to have good recycling rates and a high quality of the compost or digestate that we can use. So in general, I think in Germany we did the first steps, but not more, and we have to increase the speed to create a sustainable circular economy, and also the energy system based 100% on renewables. And it's not only a German project. We in Germany have to cooperate with all the partners globally, especially India and China. They together have 40% of the population of the world, and these big countries must be also find the right solution in the next time. So thank you very much for your attention, and now we have also the possibility for some minutes to discuss if you have questions. There's one question. In your opinion, what is the efficiency of biodiesel? In Germany, the management of the collection of used cooking oil. What's the expectation that biodiesel replace the normal diesel in the future? Are the biodiesel considered sustainable? Yeah, I think if you use used cooking oil, it's a sustainable way. This is also one point we did also in different projects, and it's also working in the industrial scale. We had also before 2008 a market in Germany for 100% biodiesel. Myself, I had a car and use also biodiesel, and it's sustainable and a good way to have a sustainable mobility, but then we changed the policy in Germany. So in 2008 we decide that we have no biodiesel market by 100%. We decide we put 5, 6, 7% of biodiesel in the normal fossil diesel. So if you go now to a gas station and put diesel in your car, 5, 6, 7% is biodiesel in this way. So I think in Germany we don't have 100% market in the future. It's a mixed market, but from the ecological point of view, it's an important issue to create this also for the future. If you have some questions afterwards, you can also contact us, and if you are working or interested in working, if you are in a master program or something here at the University of Rostock, it's also possible to do the master thesis in some of our projects. So this is also possible. So I think there's no other question. Yeah, then I can say thank you very much, and I will give the word to our moderator, Elisabeth Reich, so she can have some closing words.
Yeah, thank you very much for being here, for your presentation, for having given us an insight on your research as well, and on the issues we are currently facing in Germany. That's it for today. Thank you, Professor Nelles. We might see each other next year again here, hopefully.
Sure.
And goodbye.
Bye.